And I'm back again. This is going to be elastic collision analysis video number 10 already. So today we're going to be looking at, well, it's still the same day as the number 9, but we're also going to be looking at so this guy here, La Physique à Distance, which is a French physicist or amateur physicist, I don't know. And he's also going to do an elastic collision experiment. This time with a mass ratio of 1 to 3. So let's take a look.
Avant la collision. Deuxième démonstration.
All right, so
cette fois-ci, je vais mettre des masses dans le chariot qui est là.
So we have a metal track, and this time we have other types of carts, no Pascal carts. Well, these carts should weigh around 500 grams, and the additional mass is also 500 grams. Now he puts 2 bars in it, so we have a 500 grams versus 1,500 grams, so 3 times as heavy. Also, in this case, we have motion sensors, so that should give us accurate results before and after results after collision, also for the part 1 reflecting back, so that it does not have to travel a certain distance before it enters the photo gate. So that's the big advantage of motion sensors. So now let's take a look at the experiment.
Qu'on va laisser au repos, et je vais envoyer lui dessus. Celui-là, on va l'enregistrer. Donc, je vais partir l'enregistrement.
Here we have the chart again. That can, well, just take a look.
Voilà.
And there we go.
Alors, j'ai repris ici à l'écran l'enregistrement.
Now he's going to analyze it himself.
Le premier graphique en haut représente le chariot qui était immobile. Donc, vous voyez qu'à part un petit mouvement au début, qui est dû à je ne sais pas quoi.
So this is a heavy mass stationary at the beginning and then lifting off with a maximum peak velocity over here, which is about 0.2, I guess.
Le chariot était vraiment immobile, donc sa vitesse était nulle. C'est un graphique de vitesse en fonction du temps qu'on a ici. Donc, la vitesse est nulle. Puis ici,
la vitesse est nulle. He says the velocity is 0.
Il y a la collision. Ensuite, on a une vitesse qui est négative. Ici, négatif, ça veut juste dire que le chariot s'approche du détecteur qui était à l'autre bout. Donc, il y a une vitesse effectivement négative. On peut la noter ici, c'est moins 0,2. Quand on regarde ici.
Moins 0,2. Well, minus 2.
Juste après la collision,
minus 0.2.
ça vient à moins 0,2. Vous remarquez que tout de suite après, là, ça se met à ralentir. Donc, ici.
Right, so there's my data collection. So, oh yeah, well, first the initial velocity.
C'est quand je l'ai pris dans mes mains.
Well, you can see it probably. So this is the 0 line, and you have 0.2, 0.1, 0.2, 0.3, 0.4. So this is the initial velocity of mass 1, and it's right at the line of 0.4. And then it it's pretty unstable, but this is the peak line around 0.4 meters per second. And then it reflects back after collision at this line, which is a negative 0.2 meters per second, right? And so for the 2 carts after collision, it also reaches a line of 0.2 meters per second. Okay, so we have our data. The masses, well, he also writes them down over here.
1500 grams.
500 gram and 1,500 grams for the heavy cart. He also has the same equation to predict the collisions after collision. But I have done it also. Let's take a look. So the initial velocity is 0.40 meters per second. After collision, the cart 1 reflects back with 0.20 meters per second. And cart 2 also continues to travel with a velocity of the same velocity with 0.20 meters per second. Okay, so the prediction was, all right, if you use this equation, the prediction for part 1 and part 2 after collision is 0.20 meters per second and also 0.20 meters per second. And the measurements are showing exactly the same numbers. So we have perfect results. This equation works perfectly well. We got perfect results. All right, so now for the momentum, the initial momentum is 0.20 kilograms times meters per second. After collision, car 2 has a momentum of 0.30 kilograms times meters per second. So once again, another independent person doing this type of experiment. You have a French guy now. So on another location of the wheel. So it's in France, but it sounds like a Canadian French guy. I know, but we have another independent person, you know, doing this experiment, and he coincidentally creates another free momentum experiment because the initial momentum is only 0.20 and the car 2 comes out with 0.30 momentum. Okay. Just saying, we have all these different people around the world doing these experiments. They probably don't even know each other. Somehow they produce always free momentum experiments. All right, so cart 1 after reflection, cart 1 after collision bounces back with momentum of 0.10. Okay. So according to conventional science, in order to calculate the conservation momentum, we have to subtract them because cart 1 bounces back in the opposite direction, which has a negative value. So we have to subtract them, 0.30 minus 0.10, which gives us a total final momentum of 0.20. And the initial momentum was 0.20. Momentum is perfectly conserved. For draft science, we have to add the momentum together because negative momentum is crap, does not exist. Momentum is not a vector, it's a scalar. So we have to add them together. 0.30 plus 0.10 is 0.40, which means we end up with double the momentum. We end up with twice as much momentum as the initial momentum. This is, again, a free momentum experiment. This is bullshit. This is wrong. Cannot be true. Something is wrong. There are lots of flaws. It's manipulated. It's forced to come out conventional science way. This guy is in a conspiracy nut. It's a kinetic energy nut also as well for the 10th time in a row. So let's take a look at the kinetic energies. The initial kinetic energy before collision is 0.040 joules. After collision, cart 1 bounces back with a total energy of 0.010 joules, and cart 2 continues to travel forward with an energy of 0.030 joules. So the total amount of energy after collision is 0.03 plus 0.01, which equals 0.04, which is exactly the same as the initial energy before collision. Momentum is perfectly conserved before and after collision, and kinetic energy is perfectly conserved before and after collision. There you go. Conventional science wins. Draft science model fails once again. End of the video.